All right, so first thing, guys, you're gonna have multiple objects here, okay? You're gonna have multiple objects. You need to treat each object separately. Each object has its own individual free body diagram. And its own individual net force equation. So we're going to be combining objects here. For example, if I have a pulley system set up and I have one mass hanging here and another hanging on the other side. Okay? Elevators are great examples of this. You know an elevator has a really massive mass hanging on the other side, right? That goes up and down. All right. So that's the kind of system that we have. So while an elevator is accelerating up, the mass on the other side is doing what? Accelerating down. And so the tension in the cord is
a lot.
The same, constant. Actually ends up being constant. All right. Elevators are amazing.
Okay.
Didn't someone get stuck in one yesterday?
What?
During the power outage, someone got stuck in one.
Did they really?
Shut up, that's so scary.
That would really suck.
That happened to my sister once. They call the fire department.
I
She doesn't go
would.
in elevators anymore.
I would be
You should
flipping
ask
out.
her about it.
Wait, who doesn't go in?
I'm gonna ask her about it.
Because we were at Prince Beach House and they had an elevator and it got stuck. And she was like, "Young, do you ride out?"
Yeah, I do.
Oh.
All right, so another thing to mention, guys, acceleration is the same for connected objects. So when objects are connected together, acceleration is going to be the same. Okay? And that makes sense, right? If you take let's say your car is broken down, you need to pull it with another car. What do?
Tie them together.
Tie them together. Is the car behind you going to accelerate differently than the car that you are driving? You hope not, right? That would be weird.
Oh, that makes sense.
They're connected by one rope, so they're going to accelerate together. Cool? All right. But then there's Newton's first law. So you want somebody in the other car? Yes. Yeah. Okay.
Oh, true.
I know. Yeah, I've seen it happen. This is really bad. Huh?
If you don't have someone in
So
the
somebody
other
pulling a car, right,
Uh-huh.
with a rope, but they were the only person.
Yeah, so when they
Okay.
stop, the cars don't.
It was cool while they were driving, but when they stop, car behind you does not.
They get run over?
Huh?
No, they crash.
No, they get run over. They just crash into each other. It's
Oh,
hilarious.
he was in a car?
Huh? Yeah.
Oh.
Just rear-ended himself. Good job. It was special. Look at tension. It's amazing. Tension is the same on both sides of the string. Why is tension the same on both sides of the string?
Because, like,
It's the same string.
It's the same string. Beautiful.
We need to draw those.
Okay. Good idea. Okay. And Newton's third law says that for every action equal and opposite reaction, right? So if I pull string here, that string gets pulled that way also. There's only one tension in the rope, okay? Between any two objects, there exists only one force. Cool? Two objects, one force. All right.
Wait.
No, you're good. I know.
No.
So they can be even if they're going the same, or even if they aren't going opposite direction.
Yes, yes. Even if they're going opposite direction, the tension will be equal. Okay? So, example of that is the truck. What was that called? It's like popular 2 years ago or something like that.
Car?
Where you had two trucks pulling, right?
oh,
One rope. Yeah. No, it's like
What's it called?
redneck tug?
I don't know. It was
Redneck
pretty
tug of war?
redneck. Yeah. Redneck tug war, I guess. But yeah, it
Oh,
was.
you see which ones?
Yeah, you see which one's more powerful. So they would do a
No.
Chevy versus like a Toyota or something, like a Tundra versus a Chevy.
No,
And they tie them together, and then both would speed up as just floor it. See who won.
Wow.
The rope only has one tension, right? Even though they're both pulling away from each other.
Shoot, that's awkward.
No.
I didn't see any when the rope broke. Pretty good rope.
Usually they rip off the bump.
Like, what
Yeah,
is
usually
it?
bumper.
I started thinking
Takes a
about
lot
Ryan,
to
like,
rip.
going to
Yeah,
the
rope's
States.
good.
Shoot, that's
Especially when it's
awkward.
Exactly.
Because we have an old Ford 350.
All right.
And it has a stick.
So we're good?
Ford F6.
Almost. So,
No stick.
look here. Tension pulled up.
Our stick's better.
Now,
Yes. Oh, super.
would the tension in this rope be the same as the tension in these two ropes down here?
No. Yes.
No. No. Why? It's not enough.
Because it's carrying all of that below it.
Exactly. This rope is carrying two objects. This rope is carrying how many objects?
One.
One. Does that make sense? So which one would have less tension? This one. Does that make sense? Yes?
Oh, wait, it's talking about the top one.
Yeah, top or bottom. So the bottom would have less tension because the bottom is only carrying one weight, whereas the top is carrying two. All right? All right, so several forces on a side. What happens when you have more than one force on a single side?
That's
The world ends.
That's what happens.
What?
Okay? So, here, what do you know about the y direction? What do you know about net force in the y direction? Should be equal to 0, because force of gravity is equal to normal force here, right? Now, what about in the x direction? If I were to write out a net force equation, what would it be?
FA equals T1 plus.
T1 plus F or T minus F.
Okay? First I gotta figure out which way I'm accelerating, right? Hey! Sure.
Just call your board a jerk.
Oh, yeah, no. I didn't. Alright, so,
Abusive.
first I gotta figure out which way I'm accelerating, guys, because remember, the direction of acceleration is going to determine which way is positive, right? So if you look at these forces, just based on the arrows alone, which way should you be accelerating? Acceleration should be to the left, okay? So if acceleration is to the left, then net force is also. So therefore, F net here should be equal to what? You do positive first, right? Yeah.
Wait,
So it's going to be T1
Going that way.
plus force friction. I'm going to put that in parentheses because I got to take care of that first, right? That's one side. Minus FA.
How is it accelerating?
Tension, yeah.
That's a good question.
Hey, if friction's
Yep.
if friction's going that way, how is it accelerating that way?
Oh, because it's being applied. Wait.
Velocity is in that direction. Okay? So velocity is going to the right, but I'm
being
accelerating to the
applied
left.
that way.
Yeah. So basically, this is an extreme slowing down, right? I'm slowing down very, very quickly. So this is like, a good example of this would be bungee cord running. Have you ever done that?
Yep.
Okay. Where you're running forward, okay?
You have someone.
But think of it like you're running forward and you're on a like a skateboard or something, right? So you're on a skateboard and you're trying to run, trying to skate forward, and then there's a bungee cord that pulls you back, okay? Bungee cord is applying tension while you're applying a force forward, right? You're applying force forward, bungee cord is tension back, plus you have friction going in the opposite direction where you're moving, okay? Eventually what happens to you? Yeah, you stop and you swing back, right? Eventually. But for right now, I'm just slowing down very rapidly.
So it's like running with a parachute on your back.
Yeah, it's another way. Good way of putting it.
Never seen that.
Forces at angles. It's a beautiful, beautiful thing. What do you think we have to do when a force is at an angle?
Let's draw it first.
You have to find it in the X and the Y and then
X and Y, yay! That's it.
Sine and cosine.
Sine and cosine. It's a beautiful thing. Oh yeah. The dotted lines, this is F pull sine theta, and this one's F pull cosine theta. And again, those are components of F pull, right? I'll give you the angle I'm pulling at. This is actually something that's more related to things you'll do in everyday life. For example, if I'm pushing a push broom, right? Do you push broom straight? No, that would be really weird, right? It wouldn't work very well. Push broom is always at an angle. So, what would happen to your normal force? You're pushing down and forward.
So it would
Increase. Pretty simple, right?
What about your FG?
FG stays constant. FG is always going to be the weight of the object, right?
Yeah.
So FG is still going to be the same, but now you have an additional force pushing down. That additional force gives you additional normal force. Cool? All right, so if I were to do a net force here, net force equation, in the x and in the y, what would it look like in the y?
plus
Okay.
sine theta.
So, you know that it's not accelerating in the y, right? In the y it's not accelerating. It says acceleration is completely to the right, so we're just going to decide which way is positive. Which way is positive? Up? Sounds good to me. So you're going to say Fn plus F pull sine theta. Okay, and that's all 1 minus Fg.
So it's like the same thing for
Correct. So in this one, if I wanted to find Fn, then what would you have to do? You're going to add Fg to Fnet, right? Which Fnet should be equal to 0. Shouldn't this be 0? So 0 is equal to Fn plus F pull sine theta minus Fg. So to get Fn by itself, you would end up with adding Fg. So Fg is equal to Fn plus F pull sine theta. Okay? And now what could you do? Subtract F pull. So minus F pull sine theta. And so Fn is actually equal to less than what it used to be, correct? It's less than the force of gravity. In fact, it'll be the force of gravity minus F pull sine theta. Does that kind of make sense?
So it can change?
Huh?
So Fn can change?
Fn can change, because Fn, guys, is like a scale, right? The scale only reads what normal force I'm applying. If I jump on a scale, it reads that I weigh a lot, right? Whereas, oh, because it's not accelerating in the y direction. That's a good question. Yeah, guys, if there's no acceleration in the y direction, see acceleration is completely horizontal? Since there's no acceleration in the y direction, then Fnet in the y has to be equal to 0.
We're going to have
Okay.
acceleration at an angle.
That's mean.
What is that like the next slide?
No. I don't think so. We have a few. But yeah, that's what ends up happening. And so your normal force here is actually less because you're pulling up, okay? If I take this chair here, okay, and just pulling it horizontally, the chair is exerting the same gravity and normal force, right? But when I start to pull up on the chair, it just became lighter, and now it's easier to pull, right? So that's the reason why you pull things at angles, it takes away some friction. Does that make sense?
Uh-huh.
Okay. like ramps, and that's what we're gonna deal with. You know what? I don't know if we're gonna get into it today. Maybe we'll just stick to combining forces today and do ramps next time and really buckle down on ramps next time. Because I think that it might be too much info to go over ramps today too.
I agree.
I think we should just stop now. I already feel a little overwhelmed.
Stop all overhead.
See, that's what I thought too.
Oh, we have to do FNet and the X. So, FNet in the X is equal to what?
FN minus NG.
In X, in X.
Oh.
Yeah, there's only one thing in the X, right?
AMA.
Good. That's the only thing in the X.
What about applied? Is it because you assume that it's moving, right?
It is moving. It's accelerating based on the pull that's in cosine theta. Okay?
That's it?
That's just it?
Yep, that's it. So it's F pull. There's no friction. This is a frictionless surface.
Will these always be on a frictionless surface?
Negative.
No, thank you.
All right, so are we good?
Art and soul.
X and Y?
Please no. Please no. Please no.
Huh?
It's a metaphor.
For how much
That's it? Huh?
What about the acceleration?
So the acceleration is going to be based on that. Okay? So my acceleration, guys, F pull cosine theta will be equal to mass times acceleration, right? So if I wanted to figure out what the acceleration is, then F pull cosine theta is equal to mass times acceleration. Okay? So to get acceleration, I would just divide by mass. That'd be F pull cosine theta divided by mass. Does that make sense? Kind of. It's all F is equal to ma. We're just adding more stuff onto the end of F. All right. Next.
Sure.
All right.
Where's your conference at next week?
Number one. Huh?
Where's
All right, guys. Number one.
Stuck on your.
So
Your stick hand.
Like the one or two that actually.
it says find the tension in the rope
Oh, we're doing number one?
and the acceleration of the system. Yes.
No, we're doing number one.
The body.
Find the tension in the rope and the acceleration in the system.
There, but it was like.
Stop.
Can I have one? I didn't get it back.
I do they're over there.
Oh, I didn't.
Who is on fire? I can't tell you. It's the week leading up to it. All I hear about is the calendar.
Anybody else see one?
Look, this is
Great.
great.
This is great.
It was
Oh,
pretty
wow.
amazing. It was just I wish
What?
It's going to go
Can I have it?
Yeah.
Are you making it for me?
Yeah.
Anybody else? We're good? All right. So number one, guys, find the tension in the rope and the acceleration in the system, of the system.
probably the most judging people.
So we have two objects, therefore we have how many free body diagrams?
2.
Two, good. So, for the first object, the 15 kilogram mass, what do we know?
No, it's 15 kilograms.
Okay, so we know that it's 15 kilograms,
Are we done taking?
And it's accelerating to the right.
okay? We know that it's accelerating to the right, that's good. So acceleration is to the right.
Does not make sense because it would be accelerating. Actually,
It will be.
what if we're going to push it?
Nope. I'll show you. So, what do we know about this 15 kilogram mass? What's the first force that you can always put on something?
G.
Yeah, force of gravity, or mg, down. Okay? What should be up here? Fn, because it's on a table of sorts. So Fn is upward. What else do we know?
It's going to the right.
It's moving to the right. So velocity here is also going to be to the right. And so therefore friction should be which way?
The left.
Good. And how do I know there's friction?
Because it's on a
It doesn't say that you have.
You see it has a mu? Okay? The mu is a hint. So the mu is the hint that it says there is a coefficient of friction, therefore there has to be a frictional force. So we know we have a frictional force this way, force of friction that way. And what do we have going to the right?
Velocity
force.
flight force.
Oh, the thing. Okay.
F pull due to the tension of the rope, right?
Right.
So I can call this F tension or just a capital T tension. Either one works. Now, why did I make tension bigger than F friction?
Because it will be.
Yeah, because it will be accelerating, right? It already told me it's accelerating to the right, so I definitely know that my forces need to be going to the right. The sum of all forces need to be to the right. So, in the x direction,
She's waiting for you.
yeah, let's figure out the y first. So F net in the y. F net in the y is equal to 0. And so F net in the y is equal to, I know that Fn is going to be first, so Fn minus mg, okay? Therefore, Fn is equal to mg. Everybody okay with that statement?
Yes.
Good. So now I have my equation for Fn, and I can say that Fn is going to be equal to 15 times 9.8.
147. Yeah.
Good. So Fn is equal to 147 newtons. Okay? Why do I need Fn?
So you can find force friction.
Yeah, so I can find frictional force, right? I know that frictional force, F friction, is equal to mu times normal force. And so right away I can find what the friction is. F friction is going to be equal to, what's mu?
0.3.
Yeah, 0.3 times 147.
44.1.
So force friction is equal to 44.1 newtons.
Wait,
Everybody okay with that?
stay there.
Okay, good. We'll stay there for a minute.
No, I mean like you're,
Oh, okay.
That's what I meant by stay
My
there.
bad. Wait, stay to where I can actually see it.
Yes.
Okay. There's that.
So in the way. No.
I'm always in the way.
Yep.
It's because I don't want y'all to see.
I'll let that
Y'all are
reflect in my
hurting
next
the curve
text
of
grade.
everybody else in this class.
I will let that reflect
they
my
are?
next.
Yeah.
Are they seriously?
No.
Yeah, they are.
Kick them out?
There is no curve.
Yeah, I was about to say.
There's no curve.
Yeah, like that's not a thing.
What's up?
You should put them on a bell.
If we're hurting the curve, it's all his fault.
Better yet, you can just.
What do you mean?
put everyone on a bell.
We are solving for,
Tension and acceleration.
yes.
Oh, we're just not done?
We're not done, yeah. No, nowhere near.
What does that even
They're
mean?
fun.
Find
So
the
bad.
tension and acceleration of the system?
Yep,
Yeah, because the tension of both the ropes will be the same.
correct. So, are we good with this part here?
Kind of, yeah.
All right? Kind of. So we have frictional force now. Okay? And here's what we know of F net in the X. F net in the X should be what? I'm going to change colors here. I don't like that color.
T minus FR. FF, I mean.
Minus
Okay, we'll turn that off.
Blue. Oh, that's so much better. It's so much prettier.
Jake.
All right, what is this? F net in the X. F net in the X should be equal to what?
T minus F.
Acceleration's in the,
I think right.
to the right, so tension goes first. So tension minus
Half of that.
force friction. We have force friction, but we don't have tension. So how can I find tension in the rope?
By finding it on the 10.
Yeah. We have to find it on the 10 kilogram rope, okay? So we're gonna draw our free body diagram for the second object. Second object, what do we know is down? Well, we know this is 10 kilograms, first of all, okay? What do we know is down?
Mass grab.
Do we
Okay.
have to draw the free body diagram? Can we just draw it on the existing diagram?
Must draw free body diagram.
Oh,
I know,
There's already a box.
I know.
What do we find?
Wait, so we have to recopy this whole image?
No, you don't copy the whole image, you just have to separate it out and have two separate things. Huh?
Jose, come on.
No, well, and if they are, you still have to do a free body diagram to the side. I know it's unfortunate, guys, but you cannot do a free body diagram off of the gravity that's already there.
Exactly. Just like-
Unless I state that you can.
So weird.
For the most part, I want you to redraw it.
Can we on the test?
Nope. On the test, I'm gonna have you draw it separately. And in fact, on the test, I think last year I had separate boxes already. It was just a little box. And I wanted you to draw forces off of there. All right, so I know what's down.
MG.
MG down and
Or tension.
tension up. Everybody okay with that?
You don't need to know.
Are they equal? That's a good question.
Yes.
What do you think?
Yes.
Yeah.
I say yes. Ooh,
Wait, isn't it accelerating to the right, which means that that's
it's
going
accelerating
down?
downward, yeah.
But that's making sense. Yeah, how do we find? We have to find the acceleration in the y direction. We can find.
Correct. Acceleration here is downward. All right?
Oh, which means mg is not going to equal t.
On a test, would that be labeled right there? That acceleration stuff?
It should be.
So MG's bigger.
It's one rope, guys. So if it's accelerating to the right, if the big box is accelerating to the right, then that means that the box going down needs to be accelerating which way?
No.
Down.
So MG's bigger.
So MG is bigger.
Good luck with that.
Okay. And so here, what should I get? F net
Wow.
It did not work at all.
I know.
is going to be equal to what?
You don't need to know. It's not. It's a close.
MG
Wait till someone.
minus
Pick me.
tension.
No, it does not.
Yeah.
Oh, God.
So we need to resolve F net and X here. All right. Here's what we know. We know F net and X is going to be equal to tension minus frictional force. We now know frictional force. Yes. So tension.
Wait, frictional force in the y is equal to
It's a
frictional
sign.
force in the x.
It's a signal of divine integration.
Frictional force in the y is equal to
I'm gonna use that. Oh, I love it.
That's what I said.
I call it.
No, there's no frictional force in the Y.
What?
What?
This was this was friction in the X. We found this. Yeah. Yeah. So tension, guys. So tension will be equal to F net
No, we're not.
in the X
Time is an illusion.
plus frictional force.
There's something else I feel like I'd be a lot more on this side,
Okay?
but I'm currently just not.
And so tension will be equal to mass, which is 15, times acceleration, plus my frictional force, which is 44.1 newtons. So that's for this one here. That's for this object.
Wait, no, go back.
Now over here, we got to do the same thing. So we know mass gravity, and so tension. I'm going to add tension, subtract F net. So tension will be equal to mg minus F net. Okay? Mass times gravity is 10 times 9.8, which is 98. So tension is going to be equal to 98 minus my mass, which is 10, times my acceleration.
You just made that, and then you set them equal to each other.
Yeah, now we got to set them equal to each other, which is easier.
Why are we getting variables in there?
Because we have two missing variables, and the only way that we can do it is by spreading it out and then actually plugging one into the other. Yes.
The tension for the 15 kilograms shouldn't
Correct.
the T be negative?
Shouldn't what?
The T be
I'll
negative
take it for you.
because you're subtracting it to the other
Oh
side.
wait, so now we can put
Where?
98 minus 10a is equal to
This side,
15a.
that tension.
No. So what I did was
No,
I
the
did it
other
the
one.
opposite way.
The
This
other
one?
one. The other one.
This one.
Yeah, the T needs to be negative,
No, because T is in the positive direction.
but you subtracted it to the other side.
No, I added F friction. So what I did was I added F friction.
The meticulous taping, Ashton.
Is it 98 or
The meticulous
Huh?
taping.
Is that
I
98?
endured.
Yes, the 98 does have newtons,
I
guys.
love it right here.
Okay? Alright, so now what I'm gonna do,
That's not 9.8.
That should be the.
no, it's 98 newtons because remember that it's
I can get it now.
9.8 times 10.
Oh, okay.
Okay?
Are you serious? You'd rather do it yourself than have me do it?
Yeah, let's do it.
Alright, so
Since you broke it.
let's get back here.
You broke the whole thing.
Well, you know. Whatever.
Now I'm gonna plug one into the other, right? So I can take this tension and plug it into here, and I can say
Ashton.
I will.
98 minus 10A is gonna be equal to 15A
Are you not closing here?
plus
You
44.1.
me, don't lie.
Yeah.
So we're solving for A.
Okay, okay. I see how
We're gonna
it is.
subtract 44.1.
Oh, we did
Hold on.
keep those two tensions together.
Correct, because the tension is all the same, yes.
This is.
Which,
All right.
the other tension, which one
Which other tension? These two tensions must be equal to each other.
is it? But what is the,
Huh?
You need
This
a-
tension I got from this free body diagram.
Evidently.
This tension I got from this free body diagram. And they must be equal to each other. Okay? And so now we have,
Cute.
what's that? That's 53.9, yes?
Yeah.
Okay? So 53.9 minus 10A is equal to 15A. I'm going to go ahead and add 10A, and I get 53.9 is equal to 25A, and then I divide by 25, and I get A is equal to how much?
2.156.
2.156 meters per second squared.
You should try writing on the other side of the board.
Yeah, really.
I should, yes.
Because
Moves the yoga.
Because I'm just
with it.
blocking one side.
I know, literally, I'm just like,
Yeah.
until you move, and then
I'm just hanging out until he moves. All right. So we have this now, yes?
So we're
Yeah.
done.
that's the acceleration?
That's the acceleration. Now we need to find net force.
Ah.
How about?
Or
Tension.
the tension. Now we need to find tension. Okay?
Can you just plug it in?
We also need to vote.
Can you just plug it in?
You can.
And can
To
you
either
plug-
equation.
Either one? Okay.
To either equation. Now I know acceleration, so I can plug it into either equation. This one looks easier for me because it has a 10.
Don't judge
To be
me.
honest, that's the only reason why, okay? But it has a 10, so I'm going to plug it into
I
that
want
one.
someone wearing it.
So,
Oh, because of the tension. 21.6.
yeah, because the tension's 10, and it's easier to deal with the 10.
Are these the lemon?
Tension is in newtons.
Tension is in newtons, yes.
It isn't that bad.
Okay. Yeah, it's not that bad. So, I'm going to plug it in. I'm going to say
Ooh.
tension is equal to 98 minus 10 times 2.156, or tension is equal to how much? 76.5. Dude, killer. Good job, guys.
Really don't know.
Oh my god.
I'm just kind of waiting to see what happens.
Okay.
You should put one in.
Okay.
Fairly easy is not a word.
Hey, you should write a note for the movie.
Write a note for the Marie. Would you give us an example of what we should write?
She wrote she was very
I
smart.
wrote Marie Curie was very smart. I don't know what I should do.
The bow in hands is her frown.
If you could just write.
Their shrine.
We're gonna make contributions to the Marie Curie. And then one day, the spirit of Marie Curie will come back and take our test
We
for
should play
us.
Ouija in here.
We should play Ouija in here with our little cat.
Oh my god.
The shot glass!
Marie.
I broke, we were playing Ouija, and I
broke
broke
the
the
shot
shot glass. Like it shattered. And everyone was like, oh my god, it's spirits. I'm like, no, I just dropped it.
No,
Well, see, I watched you drop it, but everyone else, no one else, I watched
Ouija
you drop
boards are
it.
the
I
worst.
watched you
I
drop
don't
it,
trust
but
them.
nobody else saw it, so I'm like,
Oh my god, it's spirits.
For making a shrine
Magnesium.
for that tissue box?
Yes, no.
Look. We're gonna apparently.
Can I have it for a second?
Yeah, it's kind of delicate.
I just want to see her face closer, so I
Why
can
would you want to see
decide,
that?
so I can make a funny comment about it. Are we supposed to like
Write this down.
give her
probably.
compliments?
Bigger on the
I'll
second.
play like,
No. Oh, well, yeah.
Yeah.
I was talking to us for a second. I was like, oh, okay.
Wait.
oh yeah, I don't even get a lot of freaking ass. Oh yeah, there it is.
Huh?
Because there's no X's.
Yeah.
I could play roof if I have my
Her pursed lips beautifully insinuate her voluptuous hair.
That was beautiful.
1.96.
Okay, thank you.
Oh my god. Jackson, did you play? Yeah, you played Null. You know what? I got one of my guys. I got another letter too, because it's a way.
Yeah,
It's
she-
fine. You didn't let me play the word I wanted to. But it's okay. I was gonna play ooh. But no.
That was so weird yesterday. I swear to God, it was because I think it was the glasses that he was wearing was like facial.
Okay, so on the 0.98, you just multiplied it by 0.1.
Huh?
On the 0.98, you just multiplied it by 0.1.
Okay,
The MG
for the 31. And for facts, that is one.
Okay, MG what? For this one?
Yes, it's point.
0.1 times 9.8, yes.
Awesome.
Okay.
And the F net, that's the.
F net is mass times acceleration. Here's my mass. I don't know the acceleration, so I figured that out.
that last one.
Yep. So same thing as the last one. And now I'm going to go ahead and plug it in.
Yeah.
And so this one looks easier to plug into this time. So I'm going to plug it into that one. And so tension will be equal to 0.1 times 3.27 plus 0.98. So tension is equal to 0.327 plus 0.98. 1.307.
For which one?
Oh,
That
this
one?
one's kind of easy because it's the exact same thing, basically.
Yep. There you go. Huh?
You have to find the other one too.
Which other one? Oh, why did I subtract on this one? Okay, because on this one, if my acceleration is up in this one, okay, then the rope is going around the pulley, meaning the acceleration on the other one has to be down, on the other side.
Because they both can't be going.
Exactly, both can't be accelerating upward, that's just lifting, okay? So if one's accelerating upward this way, the other one's accelerating downward that way, okay? So since my acceleration switched, now F net is equal to mass gravity minus tension. Whereas before it was tension minus mass gravity. Completely different things. Okay?
Okay, so you have to plug it into the other one, right? You have to plug it into the right side as well? Or what is
No,
that?
you just have to plug it into one.
Okay.
If you want to, it'll end up with the same answer.
Oh, right, okay.
No. No negative tension, it's just, well, okay, so technically tension here will be negative because it's upward and acceleration's down, but that's just telling you the direction, okay? Yeah, guys, all forces basically make it the absolute value. If it's negative, that just tells you which direction it's pointing, okay? All right. Yep.
Yay.
Yay.
Entire page too quick.
It's not bad.
Right here.
So you have homework, yes?
So what problem do we have to do by next time?
Huh?
So what problem do we have to do by next time?
By next time, let me look here.
3, 4, 5, 9, 10, 11.
Yeah, 3, 4, 5, 9, 10, 11. There you go. I knew it was something.